Yes, we are going to study one of the important aspect of inorganic chemistry called coordination chemistry. What is chemistry after all? Chemistry is a one scientific language. And if we are to learn any language, then we should know terms involved in that scientific language. Coordination chemistry is with its own terms. So which basic terms are involved in the language of coordination chemistry that we have to learn? Many students think we have to buy out those terms and then learning is possible. If you apply the concept repeatedly, by which automatically you will learn, that's a proper learning. By hearting is a byproduct. It is not the main intentional aspect. What are we studying in this part? What is meant by coordination chemistry means what are coordination compounds? What is meant by central metal ion? What is meant by ligand? What is meant by coordination sphere? What is meant by ionic sphere? What is meant by homoleptic complex? Heteroleptic complex? Coordination number? With few examples I am going to explain those terms. It's your responsibility to practice various examples with the guidelines that I am providing. Just we are preparing base to study the forthcoming coordination chemistry topic. I hope you will enjoy the study of coordination chemistry. Once these terms are clear to you, you will understand this concept more perfectly, more properly, so that you will apply. I told you it is one of the important portion of inorganic chemistry from competitive exams point of view.
Let us begin our discussion to learn basic terms in coordination chemistry. Let us start with the term coordination chemistry. It is a branch of chemistry which deals with study of such compounds which involve coordinate bond. Coordinate bond is a one kind of covalent dative bond. Ligands do donate lone pair or pairs to central metal ion. Central metal ion is acceptor of lone pair and ligands are donor. Such kind of interaction between metal ion and ligand forms coordinate compounds, and their chemistry, their study is called coordination chemistry. In this slide, two coordination compounds are represented. First one where cation and anion is there. Cation is a coordination ion, and in second only anion is there and it itself is a coordination anion, coordination compound. Such kinds of the molecules or ions do involve in coordination chemistry. In coordination chemistry, metal ion remains at the center and ligands do surround the metal ion, and linkage between them is a coordinate linkage, coordinate bond. See now the next term, central metal ion. In this coordination compound, CONH3 6Cl3, cobalt is at center, while representation you are finding at one end, but in true sense that metal ion is at center and around that other neutral species, anionic species, ligand species, electron lone pair donating species do exist. Furthermore, also sphere remains. Spheres we are studying, but central portion is our central metal ion. Here in this complex, cobalt plus 3 is a central metal ion, and this central metal ion gets surrounded by means of species called ligands. And what kind of bond do exist between ligand and metal ion? Yes, coordinate bond. In this complex, CONH6Cl3, ammonia, NH3 in IUPAC nomenclature in coordination chemistry, we term it as amine. This amine is a ligand. How many ligands are there? 6 ligands are there. My point of interest here is around central metal ion donating species do exist which link with metal ion by means of coordinate bond. Such species are called ligand. Such species can be cationic very rarely and can be anionic or neutral. Many examples are there for neutral and anionic ligands. In this complex, who is a ligand? NH3 is a ligand, ammonia is a ligand, amine is a ligand. See the next term now. Coordination sphere. Means we are understanding that complex in terms of spheres. Inner sphere where central metal ion do exist and the species which are attached or linked to the central metal ion by means of coordinate bond. Which are those species? Ligands. Yes, metal ion and ligand constitutes one sphere and that sphere is called as coordination sphere because coordinate bond remains there therefore. See the next term, ionization sphere. Apart from this coordination sphere, if any ions are there, not necessarily always negative ions, positive ions also may possible. Examples I am discussing. Those ions remain free if we put that salt or compound in water, then outer portion ions are ionizable because those are not bonded by means of strong coordinate bond which has more covalent characteristics. In this complex CONH3 6Cl3, three chlorides by red color which are represented, those are free ions. I said already, not necessarily negative ions are free. Positive ions also can be free, but in this complex, chloride ions are free ion. And those ions constitute one sphere. And what is the name of that sphere? Ionization sphere. See now the next term, homoleptic complexes. If the complex possesses only one kind of ligand, only one type of the ligand, see for example here, ammonia, 6 ammonia molecules are there, they work as a ligand, but only ammonia is a chemical. Other than ammonia, no other ligand is there. Only one type of ligand. Therefore, such complexes are called as homoleptic complexes. Similarly, you will understand where more than one ligands do exist, more than one kind of, more than one type of ligands do exist, then such complexes are called heteroleptic complexes. In this complex CONH3 5Cl2, 5 ammonia and 1 chloride. These are the ligands. So ammonia is a one kind of ligand, chloride is the other kind of ligand. More than one type of ligands are there. Therefore, what is the name of this complex? Heteroleptic complex. See the next term now. Coordination number. What is that number? It is a number of coordinate bonds around the central metal ion due to ligands is called as coordination number or number of donor atoms. Listen carefully. Number of donor atoms around central metal ion is called as coordination number. In this complex CONH3 6Cl3, 6 ammonia molecules are there and each ammonia molecule donates lone pair through nitrogen. So nitrogen atom links to the cobalt plus 3. So how many nitrogen atoms are there? 6. Therefore coordination number 6. How many coordinate bonds are there? 6. Therefore coordination number 6. Few where it is said number of ligands is called as coordination number. It is not true. Number of bonds, number of donor atoms around the metal ion, that's our coordination number. Total number of coordination linkages, that's our coordination number. In this complex, what is the coordination number? 6. It is represented by red color. See the next term. Charge on metal ion. In this complex, charge on metal ion is plus 3. How to find that? Let me consider that charge as Q. Other basic aspects I need to know. Ammonia is a neutral ligand, so it carries no charge. Such how many ligands are there? 6. So I mentioned 6 into 0. And in that complex, 3 chlorides are there. Each chloride carries minus 1 charge. See, it's a basic. Chloride carries minus 1 charge, ammonia carries no charge, water carries no charge, carbon monoxide carries no charge, NH2 minus. So NH2 carries minus 1 charge. En, ethylene diamine, carries no charge. Oxalato, OX, minus 2. Oxalato carries minus 2 charge. Sulfate, SO4, carries minus 2 charge, SO4 minus 2. So that's a basic. Once you know the charges on the other species, means ligands, means which are in the coordination sphere, and the ions which are in the ionization sphere, or the outer sphere, then we can find out the charge on the metal ion. Here I was knowing the charge on ammonia, that's a 0. I was knowing the charge on chloride, that's a -1. Therefore, I could find charge on the cobalt, that's a Q is equal to +3. Likewise, we can find out the charge on the central metal ion. Here, for practice, I had considered 8 complexes, and I am going to discuss the terms which we have studied now for all 8 complexes one by one. Let me discuss coordination sphere as a term for all 8 complexes. First complex is a very interesting complex. See, the things which are in coordination sphere means the things which are in square bracket that constitute coordination sphere. What is there in coordination sphere? Metal ion, cobalt. Charge we will find later on. And ligands. How many ligands? 4 amine ligands and 2 bromide ligands. But if you see, how many such square brackets are there? 2. Means how many such coordination pairs are there in that complex? 2 such coordination pairs are there. Those are attached to sulfate ion. See the second complex. Interesting. PTNH34, it is a one square bracket, means it's a one coordination sphere. And PTCl4 is other square bracket, so it is other coordination sphere. So you will understand now coordination sphere means entities which are in square bracket. See the third complex, CrEn thrice, which is in square bracket, that chromium and ethylene diamine, 3-ethylene diamine constitutes coordination sphere. See the fourth complex, PDNH3 twice Br2. All these 5 things are there in the coordination sphere. Palladium, ammonia and bromide. How many ammonias are there too? How many bromides are there too? All they constitute coordination sphere. So out of that coordination sphere, nothing is there. So alone coordination sphere can be the complex, but without coordination sphere, coordination complex is not possible. See the fifth one. See, potassium, metal ion is outside, so it is not a part of coordination sphere. But CuCl5, whatever is in square bracket, no, that is our coordination sphere. See the sixth complex, Zn, NH3 twice and Cl2. So 2 chlorides, 2 ammonia and 1 zinc ion. All those constitute coordination sphere and those are represented in square bracket. See the seventh complex, cobalt and carbonate. Carbonate means CO3 minus 2. Such how many carbonates are there? 3. All those are in square bracket. That is our coordination sphere. And in last complex, chromium and 3-ethylene diamine. All they constitute coordination sphere. Those are included in square bracket. So what's the conclusion? Entities which are represented in square bracket constitute coordination sphere. I hope now this term is clear to you. Now see the second term, ionization sphere. Outside the coordination sphere, those spaces are in ionization sphere. In the first complex, who is out of the square bracket? Yes, SO4 minus 2, that is in ionization sphere. It is a very interesting example for ionization sphere. Here 2 complex ions are there. One is PTNH34 and other is PTCl4. For PTNH34, charge I am not mentioning, after us we will discuss that. PTCl4 is in ionization sphere, and for PTCl4, PTNH34 is in ionization sphere. Both species are themselves coordination spheres. See this third compound in CrEn3NO3 thrice. Out of square bracket, NO3 thrice are there, and these NO3 thrice constitute which sphere? Ionization sphere. See in the fourth complex, out of square bracket, nothing is there. So in ionization sphere, nobody is there. See the fifth complex, out of this square bracket, who is there? Only potassium is there. 3 potassiums are there. So these 3 potassiums, let the charge on them be positive, but they remain in ionization sphere. In the sixth complex, nothing is there outside the square bracket. So nobody in the ionization sphere. In seventh complex, out of the square bracket, nothing is there. But charge is there on the coordination sphere. So what coordination sphere is there? It itself represents ion, complex ion. But ionization sphere as such is not present here. In this last complex, ionization pair as such is not present there. Complex is in ion form, but ionization pair is not there. Now let us see the next term, lepticity. For first complex, which ligands are there? Ammonia and bromide. Two different ligands are there. Means what will be its lepticity? Homoleptic complex or heteroleptic? Yes, it is a heteroleptic complex. Now here, two different complex ions are there, one in one square bracket, other in other square bracket. Each complex has only one kind of ligand. In this first, ammonia is a ligand, and in second, chlorides are the ligands. So two homoleptic complex ions are combined here. It is a special case. In this third complex, which ligands are there? Only ethylene diamine ligands are there. Only one kind of ligand. So it is a homoleptic complex. In the fourth, two different kinds of ligands are there. One is ammonia and other is bromide. So it is heteroleptic complex. In fifth, only chlorides are the ligands. So it is a homoleptic complex. In sixth, one ammonia is a ligand and other chlorides is other kind of ligand. So two different kinds of ligands are there, therefore it is a heteroleptic complex. In seventh, only carbonate are the ligands. So again it is a homoleptic complex. In eighth complex, only ethylene diamines are ligands. So again it is a homoleptic complex. I hope homolepticity and heterolepticity concept is clear to you now. Now let us find coordination number for first complex. Here ammonia can form one bond. One ammonia can form one bond. So how many ammonias are there? 4. Bromide can form one bond. So how many bromides are there? 2. So 4 plus 2, 6. So coordination number is 6. So in this complex ion, 4 ammonia are there. Ammonia is a monodentate ligand. So 4 bonds it can form. So 4 is a coordination number for one coordination pair or one complex ion. And for second complex ion, 4 chlorides are there. Chloride also is a monodentate ligand. So 4 is a coordination number. So coordination number for first sphere, coordination number for first complex ion is 4, and coordination number for second complex ion also is 4. Now say third complex. Here number of ligands are 3. But which ligand is there? Ethylene diamine. Ethylene diamine is a bidentate ligand. It forms 2 bonds. One ligand forms 2 bonds. Such how many ligands are there? 3. So what is the coordination number? 3 into 2 means 6 is a coordination number. See this fourth complex. How many ammonia are there? 2. How many bromides are there? 2. Each ammonia and bromide forms only one bond. All are monodentate here. So how many total bonds are there? 4. So what is the coordination number? 4 for this complex 4. Now for complex 5. How many chlorides are there? 5. So coordination number 5. In complex 6. How many ammonia are there? 2. How many chlorides? 2. So total number 4. So what is the coordination number? 4. Now in case of 7 complex. How many carbonates are there? 3. But carbonate is bidentate ligand. One carbonate forms 2 bonds. So 3 carbonates can form how many bonds? 6 bonds. So what is the coordination number? 6. Now see this complex, last complex. Ethylene diamine thrice. Ethylene diamine forms how many bonds? 2 bonds. So how many ethylene diamines are there? 3. So total number of bonds? 6. So coordination number is 6. Now see the last term, charge on the metal ion. Now in this complex, if I consider charge on cobalt as Q plus charge on ammonia into 4 plus charge on bromide into 2, again twice is there, plus charge on sulfate is equal to 0 should be there. So just solve. You consider Q here, charge on ammonia is 0, charge on bromide is 2. What is answer? Answer is plus 3. Cobalt carries plus 3 charge here in this complex. Just work for this example. Keep in mind that here twice is there. So Q plus 0 minus 2 you will keep in bracket, into 2 you will do, plus SO4 carries how much charge? minus 2. Minus 2 is equal to 0 should be there. Means what will be our equation now? Q plus 0 minus 2 into 2 minus 2 sulfate is equal to 0. So what will the value of Q? Plus 3. So what is the charge on metal ion? Plus 3. Now see this complex. Here two platinums are there. So different charges may possible. But for the sake of simplicity, I am considering now only one term. That's a Q. Q plus charge on ammonia 0 plus Q charge on chloride minus 1 into 4 minus 4. So what we are getting? Q plus 0 plus Q minus 4 is equal to 0. So what is 2Q is equal to 4. So what is Q? Plus 2. So charge on each platinum is plus 2. There are possibilities where charge on such metal ions can be different. When IUPAC nomenclature will come, at that time we will discuss this point. Now see the third complex. Q plus charge on ethylene diamine is 0 into 3. 0. Charge on nitrate, NO3 minus. So minus 1 into 3. Q plus 0 plus minus 3 is equal to 0. So Q is equal to plus 3. Charge on chromium is plus 3. Now see the fourth complex. Ammonia carries no charge. Bromide carries minus 1 charge. So what will your equation? Q plus 0 minus 2. Why 2? Because 2 bromides are there and each bromide carries minus 1 charge is equal to 0. So what is the charge on palladium? Plus 2. See the fifth complex. Potassium carries plus 1 charge. Chloride carries minus 1 charge. Now what is the equation? Plus 3 plus Q minus 5 is equal to 0. Then what is the value of Q? Q is equal to plus 2. So charge on metal ion, that's a copper, is plus 2 here. See the sixth complex. Ammonia carries no charge and chloride carries minus 1 charge. Now see equation. Q plus 0 minus 2 is equal to 0. Why 0 I am saying? Because complex has no charge therefore. So what is the Q? Q is equal to plus 2. So charge on zinc is plus 2. Now see the seventh complex. Before that, carbonate carries minus 2 charge, CO3 minus 2. Q minus 6. Why minus 6? For one carbonate minus 2, 3 carbonates are there, therefore minus 6 is equal to, see here not 0, here minus 3. So Q minus 6 is equal to minus 3. So what is Q? Q is equal to plus 3. So the last complex. Charge on ethylene diamine, 0. Q plus 0 is equal to plus 3. So what is Q? Q is equal to plus 3. So charge on chromium is plus 3. Yes, with these 8 examples, I made these terms clear. Yes, see, as a homework, the question for you, the complex COEN twice Cl2 plus is in front of you. You have to find charge on metal ion, that's a cobalt ion. Maybe plus 2, maybe plus 3, maybe plus 4, whatever that answer is there, that you have to write in the comment box. It is a first question's answer. Now second question, what is its coordination number? Whose coordination number? Central metal ion's coordination number. How many ligands are there? How many bonds are formed exactly? That you have to find out and you have to mention that number. Maybe it is a 4, maybe it is a 2, maybe it is a 6. That number you will write in the comment box. These 2 questions answer I want in the comment box. I am waiting for your answers.